Alright, first of all, introduction for our presentation. DC motor span control is widely used in industry, used in robotics, conveyor system, and automation. Closed loop control ensure actual speed follows reference speed. Feedback from tachometer improve accuracy and stability. And if you can see, this is block diagram that I use in my uh, assignment. Next is our system model. There is closed loop control system, which is my system model is under the block diagram. And for the transfer function is GS25 over S power by 2 plus 4S plus 25. And it is second order system, and unity feedback also I use MATLAB Simulink.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azharil Hakim bin Rashidi. For slide 5, I would like to explain the performance calculation for our DC motor speed control system. From the transfer function, we calculated the natural frequency, which is 7.071 radians per second, and the damping ratio, which is 0.2828. These values were then used to determine the system transient response. Based on the calculation, the peak time is 1.463 seconds, meaning the system reached its maximum response in about an half second. The settling time is 3.0 seconds, which is the time required for the output to become stable. The calculated overshoot is 39.5%, indicating that the system exceeded desired speed before settling. This result show the system is overdamped, providing a relatively fast response but with noticeable overshoot. Okay, I would like to continue with slide number 6, that is a MATLAB simulation. After completing the theoretical calculation, we verify the system using a MATLAB simulation. The simulation produced a peak time of 1.48 seconds and settling time around 3.2 seconds and overshoot of 39%. These simulation results are very close to the calculated values. The small differences are expected because of numerical approximation and simulation settings in MATLAB. Overall, the simulation confirms that our mathematical module accurately represents the behavior of the DC motor speed control system. Okay, lastly, I would like to continue for my last slide, that is slide number 7, comparison. This slide compares the theoretical calculation with the MATLAB simulations results. For the peak time, the calculated value is 1.463 seconds, while the simulation gives us around 1.48 seconds. The settling time changes slightly from 3.0 seconds to 3.2 seconds, and the overshoot changes from 39.5% to 39%. As we can see, the differences are very small. This shows that the theoretical calculations are accurate and successfully validated by the MATLAB simulation. In conclusion, both methods produce a consistent result, proving that the proposed DC motor speed control model is reliable and suitable for performance analysis. Thank you.
Hi, Assalamualaikum. My name is Muhammad Aiman bin Azlan, and now I will explain the stability analysis. The transfer function is shown right here. So we use the Rapp-Hurwitz criterion to check whether the system is stable. So from the calculation, the results show that the system is stable when the k is greater than -1. So right here, we can conclude that the system is stable for k more than -1. Okay, for the next slide is show that the steady state error. For the step input, the steady state error is 0.5. For the ramp input, the error is infinity. For the parabolic input, the error is also infinity. Based on this result, we can conclude that this is a type 0 system. It has a finity error for a step input, but an infinity error for ramp and parabolic input.
Okay, next, my name is Muhammad Adham. I will discuss the result obtained from our DC motor speed control system. Based on the response graph, the system is underdamped, which means the output reach the desired value is some oscillation. We can also observe that there is an overshoot before the system reaches its steady state. It is normal characteristic of an underdamped second order system. The MATLAB simulation result closely match our theoretical calculation, showing that our mathematical model is accurate. In addition, the closed-loop feedback improved the stability and performance of the system by reducing the effect of disturbance. Therefore, this control system is suitable for DC motor speed control. Lastly, to conclude, we have successfully modeled and analyzed the DC motor speed control system using MATLAB. The simulation results agree well with our theoretical calculation, proving that the model is valid. We also found that the system is stable for k greater than -1. Since this is a type 0 system, it has a finite steady state error for a step input. Overall, this project demonstrates that the design control system is suitable for basic industrial DC motor speed control. So, I think that's all from us. Thank you.